Hi, Mrs. Brickey here. This is Math 2, Unit 9, Section 5. We are working on inscribed angles today. So an inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of the circle. So we've got the vertex of the circle right on the edge, and then the two sides of the angles are two chords of the circle. The arc here is called the intercepted arc. So here's our first theorem about inscribed angles. If an angle is inscribed in a circle, then its measure is half the measure of its intercepted arc. So we've got this inscribed angle right here. That's going to be 1/2 of this arc measure. So for our first example here, we have central angle 120, and our goal was to find the measure of angle CDB. So this diagram is labeled. I just have this in here as a note for your, as an example for your reference. So since we have this central angle that's 120 degrees, that means this arc has to also be 120 degrees. So if our goal was to find this angle that's in red, it has to be half of that 120 degrees, which makes that a 60-degree angle. Okay, so here's a diagram. It gives us this 50-degree angle right here and a 48-degree arc over here on the edge. And our goal is to find all of the different arcs and angles in the diagram. So if this angle is 50 degrees, then this arc over here would have to be twice that. So this would be 100 degrees because that inscribed angle is 1/2 of the arc. So the arc would have to be 100 for the inscribed angle to be 50. Over on the other side, we have this 48-degree arc, and the angle right here would have to be half of that. So that's 24 degrees. 1/2 of 48 is 24. Okay, so we have found one of the angles and we found one arc. We have two more arcs that we need to find. So if we wanted to find, let's find this arc at the top first. Remember, we can always look for diameters to help us. So we've got this diameter right here, cutting that circle into two 180-degree arcs. So arc AB would just be 180 minus 100, which makes that an 80-degree arc. And down at the bottom, again, we have that diameter that creates this 180-degree arc. So this would be 180 minus 48, which is 132 degrees. And so we found all the arcs and the angles on that diagram. Here's our next theorem. If two inscribed angles of a circle intercept the same arc, then the arcs are congruent. So we have two angles on this diagram, and they both have endpoints A and D. So you can see this one is over here, and then the other one is over here, but they both sort of end at A and D. Those two angles have to be the same, and they're marked with those markings. So looking at this diagram, can you see any other angles that you know would have to be congruent? Looking at this arc over here, you can see that angle A intercepts that arc, BC, but also angle D does. So we have angle D also is going to be congruent to angle A. All right, next example. We are trying to find the value of x here. So we've got this arc right here, and we have two angles, this one right here is intercepting that arc, and this one right here is intercepting that arc. So those two angles have to be equal to each other. So we can set those expressions equal to each other. 2x plus 14 is equal to 5x minus 13. So we can solve for x by subtracting 2x, and I'm going to go ahead and add 13 to both sides so that constant's gone from that side and my x has moved to the other. So we have 27 is equal to 3x. So if we divide both sides of our equation by 3, we have that x is 9. Okay, if all of the vertices of a polygon lie on a circle, then the polygon is inscribed in the circle, and we would say the circle is circumscribed about the polygon. This type of polygon is called an inscribed polygon. Not all polygons can be inscribed. So if they are able to be inscribed, then they'll have some special characteristics. But you could, of course, always have a situation where two of the vertices are on the edge and the third one does not reach the edge. So we're talking about ones where each of the vertex falls on the edge of the circle. So our first theorem is that if a triangle is inscribed in a circle, and if it's a right triangle, then the hypotenuse is a diameter of the circle. And then this kind of works the other way as well. If you have an inscribed triangle, and if one of the sides is a diameter, then you know that it has to be a right angle. So we have sort of the second case of this theorem in example 4. In example 4, you can see that AC is a diameter of the circle, and we've got a triangle that is inscribed in the circle. And because that side is the diameter, we know that this is a 90-degree angle. Our goal here is to solve for x, so we can use the fact that the angles in a triangle add up to 180. So that would be 2x plus 10 plus 4x plus 20 plus 90. So that's my first angle, my second angle, and my third angle. And that has to add up to 180. So on this side of the equation, if I combine my like terms, I have 6x, I have a 10, a 20, and a 90. So that's 120. And so to solve for x, I can subtract and divide. If I divide by 6, I get x equals 10. Okay, here we have a diagram, and we're given that we have a 70-degree arc and a 130-degree arc, and we have an angle that is 75 degrees, and our goal is to find all of the angles and arcs in this diagram. I'm going to pull up my calculator to help me. So the first, and I'm going to primarily just work with my diagram for a minute, and then I'll come back and look through my list. So we've got angle A right here that we know, and it's a 75-degree angle. Well, that means that the arc that angle intercepts has to be 2 times 75. Whoops. 2 times 75 gives us 150 degrees. So this whole blue highlighted arc right here is 150 degrees, but you can see that the BC part of that arc is 70. So if I subtract that 70, this will give me the arc from C to D, which is 80 degrees. Okay, the next thing we could figure out is, let's figure out AB up at the top. So this arc up here. We know our whole circle is 360 degrees. So if we subtract all those other arcs, 130, 80, and 70, we should get that arc at the top. So this is an 80-degree arc, whoops, as well. Okay, so we have all of the arcs on the circle, and now we need to find some angles on the interior. So thinking about starting with angle B, the arc that angle B intercepts is the 130-degree arc and the 80-degree arc. So if I add those together, whoops, 130 plus 80 is 210, and angle B will be 1/2 of that. So I'm going to divide it by 2. So that tells me that this angle is 105. And I'll just repeat that process with angle C. Angle C right here intercepts the arc from B through A all the way over to D. So that again is a 130 plus an 80, so that's a 210. And angle C, that inscribed angle, will be half of that. So angle C is 105 as well. And finally, we have angle D down at the bottom. So thinking about which arc angle D intercepts, angle D intercepts this 80-degree and 70-degree angle both. So if we add those two together, we get 150 degrees, and half of that, because the inscribed angle is always half of its intercepted arc, is 75 degrees. So now we can answer the questions that are asked. Angle B on our diagram is 105. Angle C is also 105. Angle D is 75. Now we have an arc. AB is 80 degrees from the diagram, and arc CD down at the bottom is also 80 degrees. Okay, another theorem here. If a quadrilateral can be inscribed in a circle, then its opposite angles are supplementary. Supplementary means that they add up to 180. And then it also sort of works the other way. If the opposite angles in a quadrilateral are supplementary, then we know that that's a quadrilateral that could be inscribed. So in this diagram, I kind of have it color-coded. So the two that are across from each other, in this case D and F, those ones add up to 180. And then in the other two, the blue ones also add up to 180. Okay, here's our diagram. Our goal here is to find all the missing arcs and angles. So let's start, and we can use this new theorem. This is an inscribed quadrilateral, so I know that this angle up here and this angle down here have to add up to 180. So I can do 180 minus 110 to get that angle, and that is 70 degrees. Okay, well, I've got another opposite angle situation. I have the one on this side, which is opposite from the one on this side. So those two together have to add up to 180. So I can do 180 minus 78 to get that angle. And that one is 102. Okay, so we found all of the angles, and now we just need to get the arcs. For the arcs, just think about which angle is intercepting them. I'm going to start with this 110-degree angle at the top. Since that inscribed angle is 110, this arc has to be a total of 220, which is just 110 times 2. And so if I subtract the 125, that will give me the arc over on the side. So this arc is 95 degrees. And now I'm going to use this 102-degree angle over here. So thinking about which arc it intercepts, it's this sort of left side of the circle. Well, 102 times 2 is 204. So this entire arc is 204 degrees. So I'm going to subtract 125 to get that little arc at the top, and that is 79 degrees. To find the last arc, we could use an an angle that's intercepting an arc, but we also could just start with our 360 and subtract the other two angles. So that's a 61-degree arc. So we found all the arcs and angles in that diagram. Okay, we have one last example. We have a circle here. We're given a few of its angles and arcs, and we have some things we're trying to figure out. The first thing it asks us for is BE. That's this arc down here. Well, if you notice, it's being intercepted by this angle. So BE is just going to be 47 times by 2, which is 94 degrees. BDE. BDE is this angle, and you notice that it also intercepts that same arc. So it actually has to be the same angle as angle A. So that's also, 47 degrees. Okay, the next one we need to find is AED. So starting at A, going to E, and then up to D. That's this angle, and this one might take us a second to find. We have an 80-degree angle right here, which means this one is also 80. And we have a triangle right here, and we know that the triangle's angles add up to 180. So if we subtract the two angles that we have in that triangle, we find out that this is a 53-degree angle at the bottom. Well, if that's a 53-degree angle at the bottom, we can find this arc by doubling it. So the arc at the top that I have highlighted in yellow is 106 degrees. But this angle that we're trying to find right here is also intercepting that same arc, so it must also be a 53-degree angle. We've already found arc AD, that's 106. Angle ABD, we already have on our diagram as well, it's 53 degrees. And the last one is arc DE. Well, we have all the other arcs in the circle, so we can just start with 360 and subtract the other arcs that we know, subtract the 106, the 100, and the 94 to get that this is a 60-degree arc. Sometimes these are like, treasure hunts. You just have to keep trying to find, the angle and look for the different relationships that we've talked about. Let me know if you have any questions on your homework. Thank you.